Hi, I'm Constance Gorman, and I've been a private tutor for 14 years. Now, some of my tutoring is done face-to-face, where I meet the person physically at a location, specified either by me or the client, or I can tutor virtually. So what you're looking at now is the virtual experience, where this is how you will be seeing me. Now, oftentimes students have problems that have been assigned in class or they need to study for an upcoming test. And I have the ability to work out those problems for them through a platform called Miro Board. So I'm going to show you what that would be like. So I am going to screen share right now to show you. And as you can see, I'm still visible in the upper right-hand corner, but now I have a whiteboard showing that allows me to do a variety of functions, and I'm just going to demonstrate some of this. So today we're going to go over calculating the magnitude of vectors. Now, as a client, if you don't understand this, don't worry about. This is just purely for demonstration purposes. So in previous classes, we've had that that vectors can be drawn on a coordinate plane, and they're represented by rays. So let's get started here. So we'll look at our prior knowledge. Remember, a vector has an initial point, which I'm drawing right here, and a terminal point, which is represented by the arrow. If you recall from your geometry classes, rays have an initial point, and then, the ray continues on into infinity in the other direction. But today, and here, just to show you this other one here, these vectors can be drawn anywhere on that coordinate plane. The initial point doesn't necessarily have to be at the origin. It can begin up here, and kind of look something like that. So we know that there are properties of vectors. They have magnitude, which is a quantity, such as speed, like miles per hour. It could be a force quantity. If those of you that are in physics, you would understand that. It could be in newtons. It also has direction, and that's the reason why for the coordinate plane, because the coordinate plane actually gives us direction according to the angle and what quadrant it is located in. Now we're going to move on to determine how can we calculate magnitude. So we can do this by using math. There are actually two ways that we can calculate it. We can use the Pythagorean theorem. Many of you are familiar with it. You've been doing that probably since grade school. So here's the Pythagorean theorem formula. A squared plus B squared equals C squared. Remember, A and B represent the legs of the right triangle. So a triangle has a 90-degree, and the legs are here. Here's A, here's B, and C is the hypotenuse. Remember that the hypotenuse is always opposite the 90-degree angle. So to calculate the magnitude of this vector, which is represented by C, all we have to do is determine the length of A, and we can count the blocks. So 1, 2, 3, 4, 5, 6. So A represents 6. So I'm going to put 6 squared here. B will count the blocks here, 1, 2, 3, 4, 5, 6, 7. B equals 7, so we'll put 7 into our formula. So now we'll simplify at this point. 6 squared is 36, 7 squared is 49. We'll add those two values together, which is 85. But remember, that equals c squared, and we need c, not c squared. So to get c, all we have to do is take the square root of both sides. So we'll take the square root of both sides, and now c equals the square root of 85. And that's the magnitude. Now, the labels depend on, what values A and B are. So if it's velocity, in the realm of physics, then that would be meters per second. If it's in force, it would be in newtons. So, depending on your problem. So there's one way you can solve for magnitude is by using the Pythagorean theorem. Another way is to use the distance formula. So let's change our colors here just so we can differentiate the calculations. Now the equation is here, and x sub 2 represents the x-coordinate of point 2. X sub 1 represents the x-coordinate of point 1. And the same here, y sub 2 is the y-coordinate of point 2, and y sub 1 is the y-coordinate of point 1. So the first thing you need to determine are what are the coordinates of the initial point and what are the coordinates of the terminal point. So I'll do that right now. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So the coordinates of the initial point is 2, 8. Usually they they put that in parentheses. Now let's determine the coordinates of the terminal point. 1, 2, 3, 4, 5, 6, 7. Whoop, wait a minute. 1, 2, 3, 4, 5, 6, and then up 2. So the coordinates of the terminal point are going to be 6, 2. Now, if you want to do something that will save you from making careless errors, just identify the points as 0.1 or 0.2. And it doesn't matter which one you choose, you'll still get the same answer. So I'm going to choose this point as 0.1 and this point as 0.2. And now all I have to do is fill in the information. So the x-coordinate of 0.2 is here. This is 0.2, that's the x-coordinate. So 2 minus, notice I'm just filling in the information. The x-coordinate of 0.1 is here. So that's 6. Then you square the quantity, and let's keep going. The y-coordinate of 0.2 is 8. Here it is here. And the y-coordinate of 0.1 is right here, which is 2. We square the quantity, and then the formula calls for taking the square root of everything. So let's continue to simplify. So 2 minus 6 is a -4. So just to show you, some of you may already know the answer, but a lot of students make careless errors here because they forget that this right here means -4 times -4. And if you recall, a negative times a negative is a positive. So this is going to equal a positive number. And that answers 16. We'll do the same thing for the y-coordinates. 8 minus 2 is 6. You have 6 squared. We'll simplify 36. And for your teachers in your classroom, I would continue, just don't put 16 plus 36, include the square root symbol. It'll show her that you're simplifying. Then combine the quantities, which is 52. So now the distance is the square root of 52. You do not take the square root again because you're not using the Pythagorean theorem. you are working with this equation, okay? Not the Pythagorean theorem. All right, so let's have you practice some problems. Okay, so at your desk, go ahead and in your notebook, write down this problem as an example. What is the magnitude of the vector -9, -6? Now, just for prior knowledge, remember that's going to be in the third quadrant. So pardon my crooked lines, but remember, this is the first quadrant, second, third, fourth. You go counterclockwise. And so this vector is going to be here. I'll draw my right triangle. So the x value, I just want to point out, is going to be -9. Notice we're on the negative side of the x-axis. This is the x-axis. And then we're on the negative side of the y-axis. And so the y value over here is going to be -6. So you could do the Pythagorean theorem, or you could use this distance formula here. So I have a better diagram drawn here. It's in the third quadrant. I don't have the other axis drawn here, but you can visualize it. So here's the first quadrant, second, third, fourth. So remember, this is going to be a -6. This is going to be a -9. If you recall, that's very crucial when it comes to using the unit circle when determining trig values. The sign is very important. So that's a practice problem. You could either solve it by Pythagorean theorem, which that's demonstrated in this picture, or you can use the distance formula. And here, this is what you should have in your notebooks. We've substituted in the appropriate values. We simplified here, more simplification. And now we simplified the radical, which all of you know how to do that. Okay, at your desk, go ahead and copy down these problems, just 1 and 2 for now, and determine the magnitude of the vector given this information. Now, just to remind you that the unit vector, notice there aren't 2 coordinates here. That means the other coordinate, the initial point is 0, 0. So whenever they use that verbiage, you do have 2 points. If they use unit vector, that means the initial point is at 0, 0, the origin. And this is the terminal point here. Now, in the case of example 1 or problem 1, you have 2 points. So it's not a unit vector. And then on your own, you can go ahead, and I've drawn some vectors just to give you an example, but you can draw your own vector on some graph paper. So pull out your graph paper, draw a vector any way you want, make it manageable, so it's on your graph, and then calculate the magnitude using both methods. Because if you get the same answer using both methods, then it's correct, right? The chances of you making a careless error twice, I think, are, probably small. So go ahead and complete those problems. And if you have any questions, let me know. And this is Constance Gorman signing off.